Okay, so today's lesson we're going to be looking at real numbers. So we had a bit of an introduction last week into just some of the basic concepts and a little bit of revision from the work that you've done previously, but we're right into it now. We've got our textbooks and we are really starting to begin our first topic. So what we're looking at over the next 3 weeks, we're looking at real numbers. Okay, now what is a real number? Real numbers are essentially almost any number that exists. They can be broken into two subsets. Okay, now one of those subsets is called irrational and one of them is called rational. Okay, so real numbers are both of these things. There are two parts within real numbers. One is irrational and one is rational. Now, rational numbers are then split themselves into two categories. One is called integers and one is non-integers. So we're just going to have a little bit of a look at how to define each of these terms on the board, and then we'll move on to some practice. So a rational number can be represented as a fraction or as a whole number. So these are most of the numbers that we use on a day-to-day basis. So if I put in a fraction like this, 2 over 7 as a fraction, sorry, it's just annoying me a little bit. This would be considered a rational number because it's a fraction. If I put the number -7, it's a whole number or it's a fraction, this is fine. If I put 10, oh dearie me, 10 over 15, goodness me, sorry about all this, 10 over 15, that can then simplify down to another fraction, but it is still considered a rational number. And of course, if we just had a whole number as an integer, so just as a reminder, an integer is a whole number, a counting number. These are all considered rational numbers. Now, there's a way to test this. If you get your calculator out, I'll just pull up a calculator on here. The way I can test this, I might just go back to a simple one too. So I'm looking at this fraction here, which is the 7 over 2. If I put this into my calculator, it's 2 divided by, where's divided by 7. The answer I get, and it takes a little bit of time, but it will actually repeat. So if I have a look up here, so it's got 28571 4, and then it repeats again, 2857714. It will repeat again, 2857714. If you see a repeating pattern when you put it in the calculator, it is a rational number. So if I do I'll do this one over here will be a little bit easier to see. If I do 10 divided by 15, I get 0.66666. Now, the 7 on the end is only there because they've rounded. So that would actually continue as 6666666. If I put I mean, I can put any fraction in here. If I do 7 divided by, oh my goodness, 77 divided by 88 equals 0.875. Now, in this case, it doesn't repeat, but it stops. So this is another example of how we can tell it's a rational number. So I'm just going to put in here is that if a fraction as a decimal repeats or stops, it is a rational number. Okay? And if I did another example of this, something clear, if I just do a really simple fraction of 1 over 2, 1 divided by 2, this board is giving me grief. Then our fraction is 0.5. Does it repeat or does it stop? Then it's a rational number. Okay? So there's our definition of a rational number. Now, part of you might be thinking, well, what else is there? The main two examples that we're going to look at are called surds. Now, you may or may not have dealt with these in the past. Okay? Now, sometimes surds are rational and sometimes they're irrational. Now, a surd has a symbol. Oh my goodness, this board is driving me crazy. Okay? Now, you may have referred to these as a square root symbol in the past. And as a really quick revision, if I put a 9 in there, what two numbers multiply together, what times itself gives an answer of 9, and in this case the answer is 3. Okay? Now, this is an example where a surd is rational because our final answer is a rational number. However, if I put an 8 in here and then we get our calculator and I put in 8 and I hit the square root symbol and I hit it twice, you'll see up the top here it's got SQRT 8, so just saying that it's done the work for us. But have a look at the answer, 2.8284271 and so on. Now, there is no pattern in that at all. They almost look like random numbers. Now, this also only stops at 619 over here because it's run out of space on the calculator. That will go on until ever. This is an example of an irrational number. So have a practice on your calculator, put in some numbers. If you look at this, 25, what does that simplify to? That can simplify to 5 because 5 times 5 equals 25. That would mean that this is a rational number. But if I put in 26, put that into a calculator, and you'll see that you'll end up with an irrational number. Now, the other example that we commonly use is the pi symbol. Now, if you put that into a and I'll have to, if I put that into a calculator, you'll see over here, right over here, it's got the pi symbol. I'll put that in, and 3.14159, and so on and so on. But there is no pattern there as well. So pi is an irrational. So pi is an irrational number. Okay. Okay, so for some practice and just ensure that you've got a good understanding of the stuff that we've just covered, could you please, if you jump to page 28 on exercise 2A in your textbook, question 1 and 2, just choose 10 of them. And then once you've done that, I mean, look, if you feel like you've got it after 7, I'm really not that fussed if you want to jump on. But if you're only going to do 7 or 8, make sure you do some that are at the very end of that question. So it would be a big risk to do the first 7 and think, okay, I've got this, because the questions generally get a little bit harder. Once you've done 1 and 2, you can then go to 6 and sort of work your way backwards. You can have a choice there, but really the question you really need to answer at the end of this is, can you describe what an irrational number is and a rational number? Could you teach it to somebody else? And could you identify what an irrational and a rational number is? And could you write down an irrational or an irrational number?